Good morning, everyone. Today we're going to take a look at how a computer works and what is happening on the inside of that computer. Let me just go ahead and make myself really tiny here. All right, so let's start off with the concept of binary. Now, I mentioned binary before when we took a look at transistors and vacuum tubes, but I want to show you on the screen here, this is what the letter A is, as we know. This is its binary representation. So binary is not a programming language, it's a code. And we can make ones and zeros or ons and offs or differences in voltages mean something to us. So below all this pretty stuff I've got on the screen in this video that's streaming and all that, everything's being chunked down into binary and calculations are being performed on it. That, to me, that's just amazing. That's well beyond my skill and ability to invent such a thing, that's for sure. So just real quickly, the main components of the computer, the number one is the CPU, the central processing unit. We often call it the main brain of the computer because nearly everything goes through it. So it's a central processing unit. There's other processing units. That's what we should understand from central processing unit. There's a lot of stuff going on in there, but this is the main thing. This is where your information goes to be calculated and then put back on the screen. And yeah, moving the mouse around here is a calculation that it's performing very quickly so that the mouse can be represented where it needs to be. All right, so these days CPUs have multiple cores. In other words, they have multiple processing units inside of them, and the more the better, right? So if you got one core, it can do one thing at a time, but if you got two cores, now it can do two things at a time, and so on. And so the more cores, the better. It is also rated in a gigahertz rating. That's how many times in a second can it process information. When we started, I think the first Intel processor was like 4 megahertz, and now we're generally up to around 3 gigahertz. And so you can just take the mega, right, and it goes to giga. That's 1,000 megas. So if I say it's 3 gigahertz, that's 1,000 megahertz. So it also has different levels. So what they've tried to do is make it easier to buy the stuff by taking on some things that they do in the auto industry, which is give it a model, right? This is an I this or an I that or whatever. And so Intel, the lowest one is called an i3, and then the middle one is an i5, and then the top, no longer, I should have put i9 on there too, but the top usually for most people is an i7. An i9 is, really like a workstation class. Some gamers might get it, but it's really expensive. AMD has done the same thing. They've Ryzen 3, 5, and 7, so they followed that same numbering. And I would just say, I'll just throw this in right now, I would not get anything that's a 3. I just wouldn't do it. i5 or i7 or 5 and 7 are really the way to go. The 3 lineup is really a very, very, very low-end processor. Now, what does kind of make it more confusing is that they have generations, right? And so they've kept this i3, i5, and i7 for many, many years. And then that means you have to know, well, what was the model 2 years ago, or what was the model 4 or 5 years ago? And so they have generations, and currently they're on the 1100s. And so you've got the 1100s, the 10,000s, and then 9, 8, 7, 6. So as you go back in time, that number gets lower. That is kind of nice, though, because the more the better on multiple cores, the more the better on gigahertz, right? The 3 is faster than a 2. The more the better on these levels. The 7 is better than a 5. And then the generation, the more the better. And so I try to teach my students that, so that, years later when you're going out to buy something and you're like, oh, there's a bunch of stuff in there that McBride talked about, you can really compare models based on those numbers and say, well, the more the better. It's a higher number, so it's better than the last one. And the same with the AMD. Now, the final line here, though, the CPU is not all that matters. You can have a fantastic super CPU, but you're not enough RAM, and then you're in trouble, or not enough storage space, and then you're in trouble. So while this is the main thing that you look at and say, this is going to provide me a certain amount of speed, a certain amount of performance, it's not the only thing, right? It's not the only thing you're looking at. So just real quickly, this little graphic shows you what a CPU does over and over again internally. And so right here in step one, the control unit, so there's a control unit in there inside the CPU, and it fetches the math problem instructions and the data from memory. So it goes out and grabs it from memory. Then in step two, the control unit decodes the math problem and instructions and sends it to the arithmetic logic unit. That's what an ALU unit is. So here's the control unit. It basically says, okay, I have now figured out what the math problem is. So here you go, arithmetic logic unit. You go ahead and perform what you need to do. Then it performs what it needs to do. And then in step four, the results of the problem are stored back into memory. And then we start the whole process over and over again. And there's millions of calculations going on. And so you follow this same process over and over again, where you fetch, you decode, you execute, and store. And the CPU is just doing that. That's just one core, right? So if you've got another core, then you have the ability to divide up that work. That's where those cores come in. Now, we need to look at the interaction between CPU input and memory. So there you are typing on your keyboard down here, right? You're right here, your keyboard and mouse. And that's going to come up and be stored in memory until the CPU can do something with it. And then it'll go over to the CPU. The CPU will do that and it'll send it back. It's just amazingly, blindingly fast, right? I'm using the CPU now just by clicking on all this stuff. I click on the next one. Whoa, you know, it went through this process so fast that I couldn't even see it happen, right? That's how fast the computers are these days. So it's fantastic. So if it's slow, right, it's going to slow you down. Now let's take a look at RAM, or what's also known as memory. So a lot of times you'll see when we look at buying a computer, it's just called memory. But RAM is random access memory, meaning that it can access any data on any of these chips at any time it wants to. It's random access memory. It can do whatever it wants. And it's where you work. This is the important thing to know. It's where you work. I compare it to countertop space. I compare it to a kitchen where you're going to go in and make a meal. And if you have this much countertop space, it's going to take you a long time to make that meal, right? Just think about a sandwich, for instance. Everybody's made a sandwich. You've got a bunch of stuff in your fridge, the meat and the cheese, the mayo, the lettuce and tomato, they're all in the fridge. And that's a special storage space. And we'll get to that storage in a minute. But you have to take all that out and put it on the counter. I lived in a place once that was so small that I'm not joking, the countertop was this big, and it took me quite some time to make a sandwich for lunch every day because I just didn't have the space, right? I had to take the mayo and the bread out and do that and put the mustard on and then go get the meat and put the mayo and mustard back. And right, it was just shuffling back and forth in order to actually make a sandwich. And that's what happens if you don't have enough RAM. As soon as you double click a picture to look at, that's copying it from your storage into your countertop space where you can look at it and work on it. If you load up 10,000 photos, you're going to start to run out of countertop space, right? Now, you need to know it's rated in gigabytes, so it'll be listed as GBs. It also can be rated in terabytes, but you shouldn't be buying any memory that big. You don't need that. It does have a speed rating, but it's not as important as making sure you have enough. And generally, the more the better. So again, right, how much RAM does this have? The higher the better. So it's that concept that if we're looking at all these numbers and they're confusing to us, we can always tell ourselves the higher the better, and we'll be safe. Just so you know, just as a point of reference, Windows requires about 3.4 gigs. And so if you have a system and it's only got 4 gigs of RAM, you're using most of that just to run the operating system, just to make that go. And so as soon as you load in a picture, now you're out of RAM. The system has a way to get around that, but it makes your system slow. It makes your computer slow. That's what I should say. So 4 gig is not enough these days. 8 gig is enough. No more than 16 is needed. Right, I teach majors, right? I'll say my majors, and people be like, what are you talking about? People that are in our majors program, right? You're a computer major. And they'll come in and, oh, I'm going to get a 32 gig of RAM and blah, blah, blah. And I don't know why. Why are you going to get 32 gigs? The more, the better, but only to a point. If you have enough countertop space in your kitchen to get done what you need to get done, adding more countertop space is not going to help you. And you just wasted a bunch of money on a big kitchen that you'll never use, right? Same thing with this. It's exactly the same thing. And so if Windows is using this much, 8 gig is enough. You start get into, I'm going to run 4 different VMs because I'm going to have Linux on there and I'm going to have all this different stuff. Then yeah, then 16 would be good. The only time you would go above 16 if you're really going to do some kind of server thing, or you're going to try to run 3 games at once. I don't know, because you have enough space.